This is review video 25, writing formulas for Arrhenius acids and bases. So we've already covered what the definition of an Arrhenius acid or an Arrhenius base is. We know that Arrhenius acids have hydrogen, and we know that Arrhenius bases have hydroxide in the formula. But in terms of how to write those formulas, that is what you're going to have to be able to do successfully in this class. So for an Arrhenius acid, there are 3 total situations that you could run into when you're looking at a name. All right, so situation number 1 is first, and that is going to be hydrogen paired with a monoatomic anion. Monoatomic means one atom, right? So hydrogen and one atom. So examples would be HCl, HBr, H2S, H3P. All of those anions are only one thing, right? And so if you look at the names of those, there's going to be some specific patterns to look out for. When you have hydrogen bonded to one atom, you're going to see the prefix hydro in that name. You're going to see the suffix ic in that name, and you're going to see the word acid, such as hydrochloric acid and hydrosulfuric acid. In terms of figuring out how to write that formula out, you need to take hydrogen and then whatever the anion is, and you need to use swap and drop. And I know that we're used to only using swap and drop for ionic compounds with a metal and a non-metal, but please recall that you can use swap and drop for any compound that contains a cation and an anion. Hydrogen is a cation, even though it tends to bond covalently sometimes. So we're going to still use swap and drop. So for hydrochloric acid, I'm seeing the prefix hydro, I'm seeing the suffix ic, and I'm seeing the word acid. My other thing other than hydrogen is going to be chlorine. So I'm going to take H, and I'm going to take Cl. Hydrogen is a +1, chlorine is a -1 according to our periodic table grouping. So when I do that swap and drop, my final formula is HCl. And please recall that we do not have to write those little ones down there. It is more correct to just write it like this. All right. Hydrosulfuric acid, I'm seeing the prefix hydro, I'm seeing the suffix ic, I'm seeing the word acid, and my anion's identity is sulfur. So again, I'm going to take hydrogen, which has a +1 charge. I'm going to take sulfur, which has a -2 charge. I'm going to swap and drop those charges, and I end up with H2S as my formula. All right? Situation 2 that you could run into with an acid. You could have hydrogen paired with a polyatomic anion that ends in ate. So examples of that would be sulfate or nitrate or carbonate or any of those. In the names, you will see that they do not have a prefix at all. They still will have a ic suffix on them though, and they will have the word acid. So looking at these, I see nitric acid. I see that suffix ic, but there is no prefix, and I see the word acid. I see that suffix ic in sulfuric acid with no prefix and the word acid. I see in phosphoric acid that I have a suffix, but no prefix, and I have the word acid. So what that tells me is that I am looking at an acid that is hydrogen paired with a polyatomic ion that ends in ate. And if my root of that acid is nitr, then I'm probably looking at nitrate, which is NO3. So all I have to do is take my charge of hydrogen and I take my charge of nitrate, which you should know by heart at this point, but if you don't, it's on your polyatomic ion chart. I'm going to take those numbers, swap and drop them, and I end up with HNO3. Sulfuric acid. My root is sulfur, and I notice that there's no prefix. So instead of sulfur, I'm looking at a polyatomic ion sulfate, SO4. So I take my hydrogen, and I take SO4, which has a -2 charge, and I swap and drop them. So I'm going to end up with H2SO4. Phosphoric acid. I am looking at that root, and it's most of phosphorus. But again, I don't see a prefix, so instead of phosphorus, I'm going to be looking at phosphate, PO4, with hydrogen.
I take my hydrogen. I take my phosphate with a -3 charge. I swap and drop them. So I end up with H3PO4. Last situation you could run into, hydrogen and a polyatomic ion that ends in ITE instead of ATE, so that would be nitrite, sulfite, chlorite, any of that. Those names are, again, not going to have a prefix at all, and instead of an ic suffix, you'll see an OUS or an us suffix, but you will still see the word acid telling you that it is in fact an acid. And again, we're going to use swap and drop to write these formulas. So I see that my root is nitra and my suffix is us. So instead of nitrate, this time I'm looking at hydrogen with the polyatomic nitrite, which is NO2. Once again, I'm going to swap and drop. So I take my H plus and my NO2 with a -1 charge. I swap and drop them and I get HNO2. Sulfurous acid. So I see that my root is sulfur, but I have that OUS suffix. So instead of sulfate, I'm going to be looking at sulfite, and I'm going to swap and drop that. Sulfite also has a -2 charge, and we get H2SO3 as my formula. All right. Bases, thankfully, are much easier than acids are to differentiate and write a formula for, because they are named just like regular ionic compounds are named, because that's what a base is. It's an ionic compound with hydroxide in it. So you're always going to see the name of the metal and hydroxide at the end, and you just have to swap and drop. So we have sodium hydroxide. The name of my metal is sodium. Na+1, hydroxide is a -1. We swap and drop and we get NaOH. Calcium's my metal with hydroxide. Calcium has a +2 charge. Hydroxide has a -1 charge. We swap and drop them. We end up with this, CaOH2. Last but not least, we have iron 3. That 3 is there because iron is a transition metal, so it's there to tell me iron's charge. Fe+3. Hydroxide is still a -1. I swap and drop them, and I end up with that. So hopefully you were able to understand how swap and drop works, considering we've done it before, and apply it to both acids and bases, but let me know if you're having trouble.